Welcome to another session on pediatric fractures. We'll discuss the mechanism of fractures in children. There are different forces which are applied to the bone in pediatric age group. Sometimes it's compression, sometimes it is torsional forces, and sometimes it is bending forces applied to the pediatric bone, and they have a different effect on the pediatric bone. While looking at the graph, the force is increasing, the deformation is increasing. In first zone, there is elastic deformation. The elastic deformation is that the bone bends and returns to normal. There is no change in the architecture of the bone, and after that there is a zone of fatigue, and beyond that, if force is continuous, then there is a zone of overload, and then the failure pattern starts. Initially, the failure pattern is zone of plastic deformation. There is no fracture or the failure of the cortices, but there is increased change in the architecture of the bone, which results in failure patterns later on with the increasing force and ends up at the fracture of the cortices. First of all, compression fractures. These are the compressive forces which are applied to the distal radius. When a child falls onto the outstretched hands, there is a compression over the distal radius, and this metaphyseal diaphyseal junction is most commonly affected, and it fails in compression. It is resistant to the tensile strength, but it fails in the compression and results in buckling of the periosteum, and sometimes it is called a torus fracture. And you can see the white arrows on the x-rays showing the buckling of bone, and red arrows on the left side also showing the buckling of the bone in the metaphyseal area of the distal radius. And sometimes it ends up with the angular deformity, but it is most commonly is a staple injury and does not need any sort of intervention other than casting. So another is torsional force. Torsional force, this happens to the pediatric age group, which are different, and sometimes in very younger children this torsional may result in epiphyseal injury, but in relatively older children it is applied to the bone and it results in the S-shaped fracture line and resulting in the spiral fracture, and this involved mostly in the diaphyseal region. Then there is bending forces. When there is bending force over the pediatric bone, it bends, and it is initially in the form of a plastic deformation because there is only architectural change inside the bone, but the cortices, they are not failed. When this bending force is increased, there is a failure of the cortices over the tensile side, as you can see with the yellow arrow pointing towards the failure of cortices on the tensile side, and this type of fracture is called green stick fracture. In older children, this green stick fracture may be in the form of short oblique or transverse pattern. These are all the different failure patterns, and this green stick fracture needs to be completed for the reduction of fracture. Understanding of the forces which are applied to the pediatric bone and resulting in the different failure patterns, plastic deformation, the elastic deformation, and how the green stick fracture occurs is demonstrated in the next section or next session of video, which are demonstrating on a plastic pipe and as well as on the green stick, the different failure patterns which are commonly seen in pediatric bone.